Hello students, welcome back. We just completed section 1. Let's go to sections 2 and 3. Section 2 is about the basic properties of real numbers, and that can be classified into these three: algebraic property, order property, and completeness property. The third one can be renamed into geometric property. Yeah, okay, let's call it like that. Now, what about the algebraic property? It's about algebraic operations, addition and multiplication. Here's the content and here are the names. Everybody should be familiar to all these. Please stop the playback and read through if you need more time. Please recall the names as well: associativity, identity, inverse, commutativity, and distributivity. Next, order property, and those are related to inequalities. Everybody should be familiar with all this content here. The name may not be, but that's not really important. This may be new to you, but if you forget, that's okay. Let's analyze these a little bit. Any pair of real numbers can be compared. A is less than B, or A is greater than B, or A and B are the same. One and only one must take place. Thus the name trichotomy. You see, 3 means 3. And what does it tell you? This tells you that we can arrange the real numbers. Smaller numbers go to the left, larger number goes to the right. Is this ordering valid? Yes, it is. Look at the next property, which we call the transitivity. A is less than B and B is less than C, then certainly A is less than C. And did I say the ordering? Indeed, A is less, so it's the left of B. B is left of C. Then certainly A is left of C. Less is left, greater is right. So inequality corresponds to ordering. Next, preserves the addition. So A is less than B, and add the same thing to both left-hand side and right-hand side, then we get the same thing as before. So the ordering or the inequality is preserved after the same addition. The key is to add the same thing to both left-hand side and right-hand side. C can be negative, so I can do subtraction just as well. Finally, preserves positive multiplication. We need an additional condition here. C is positive. Then AC is less than BC if A is less than B. So the inequality is preserved once you multiply the same positive number to both left-hand side and right-hand side. Now, what if you multiplied the negative number? Actually, the direction changes. What if you multiply by 0? Then they all become 0. Then you get just equality. It turns out that the negative case can be deduced from the first. So it doesn't belong to one of the 4 main properties, but you have to remember all these 5. But then again, everybody already knows. So let's move on. Geometric property. And let's go back to whatever that was before. It has some geometrical aspect. So the set of real numbers completely fills up the entire line. Therefore, we can do some geometry like this. So if you have an interval like this, a to b, then inside is entirely filled up because there's no hole in the set of real numbers. They completely fill up. So we can consider continuity and those kind of stuffs in real number system. Here's an example of an open interval, but in this case, we can expunge some things out. There's no other hole. except for those explicitly expunged out. Okay, those were basic properties. Let's do some more arithmetic rules here as an extension of property number 1, the algebraic property. Subtraction and division, we can define those as just adding a negative number or multiplying a fraction, the reciprocal. The property of 0, again, really everybody already knows all this. Adding 0, no change. Multiplying by 0, everything becomes 0. And 0 product property, x times y is 0, then either x is 0 or y is 0, or both of them. In any case, there's no way you're going to get 0 by multiplying two non-zero numbers. Here's an example. What if you have something like this? X minus 2 times x minus 5 is equal to 0, then what do you get? What conclusion do you draw? X minus 2 is equal to 0, or x minus 5 is equal to 0 according to this property, right? First times second is 0, so either first is 0 or second is 0. Therefore, what do you get? X is equal to 2, or x is equal to 5. You can get all these. And this kind of technique is really important solving equations. And that's why right-hand side has to be kept at 0. Final property here is division property. Now, I haven't seen many students making mistake here. When the denominator is 0, undefined, but when the numerator is 0, then I see some mistakes. It's okay to have 0 in numerator as long as the denominator is non-zero. Yeah, okay, let me add that new condition here. I guess I forgot about that. Denominator should not be 0 in any case. 0 over 0 is undefined. Whenever you have 0 downstairs, that's undefined. But numerator, that's okay. For example, if you have something like 0 over square root of 17, I don't care how complicated the denominator is. It's just 0. By the way, this is actually the same as 0 times 1 over square root of 17. So certainly it is 0. Another way to look at the same thing. Properties of 1. Again, here you cannot have 0 there. 0 over 0 is not equal to 1. Here I didn't forget. The denominator should be non-zero. Finally, the properties of signs. I don't see a lot of mistakes here in college algebra level, but in intermediate algebra, I used to see a lot of mistakes. Positive times negative is negative, no problem there. Negative times positive is negative, no problem there either. But this one, I used to see some mistakes. Negative times negative is positive. All right, remember that. Negative times negative is positive. Double negative is positive. Well, I don't see a lot of mistakes there either, but sometimes I do. So, okay, here we go. And these are corresponding properties regarding divisions. But once you master multiplication, then these are no big deal. Okay, so much for sections 2 and 3. Let's stop here and let's meet again in a separate video for section 4.